It is Saturday, and that means it is time to imagine it. We're at the Imagination Station, safety first, putting on my glasses here, and I have Carl Nelson joining me, the chief scientist. And Carl, we have some big jugs here. These are something that we see every day.
Water jugs, but today they're filled with alcohol vapors.
Oh boy.
So we're going to compare 3 different kinds of alcohols and how they combust.
Okay.
If you could take that and just like invert it like I was doing and to mix it around, what we're doing is we're getting all that alcohol to coat the inside of the jug, and then we're going to pour the liquid out because I only want to ignite the vapors, not the actual liquid itself.
Okay, because the actual liquid, that would create
a melted bottle.
Okay.
Yeah, it'd actually melt the whole bottle for us here. So we don't want to do that. So I'm going to pop this off and actually drain the liquid into this beaker.
All right. Now you said 3 different kinds of alcohol.
This is 95% ethyl alcohol.
Okay.
Over here we have some rubbing alcohol, and then finally some methyl alcohol.
Ah,
so
okay.
I'm going to get this one draining as well.
All right.
Takes a few seconds for all that alcohol to get out. Now, I think this guy's probably good. Your role is going to be actually to ignite the vapors.
Okay.
Okay?
Sure.
So what I'm going to do is I'm going to flip this over, we'll stick it near the edge of the table here.
Alrighty.
I'm going to ignite this stick, and here's the tricky part is you have to kind of hold the stick up in the air and come down towards the opening where the vapors are.
Okay.
So just bring it right in there, get right into the opening.
Oh boy,
yeah.
Wow.
So,
okay, so that was a lot of power. Yeah.
There's a lot happening there.
Yeah,
I'm gonna get our stick.
Happy birthday to everyone, because I think those birthday candles went everywhere, but that shows, boy, Carl, the power involved with this one.
That was, yeah, a little startling.
Yeah.
As you can see.
You know what? You always keep me on my toes, and that's why I love you.
I'll give you this one again. Okay, so that was ethyl alcohol.
Okay.
All right. Now we're going to move on to isopropyl alcohol, which is...
and this is something that we all have at home. This one, this next one, right?
This is something you have at home,
okay.
Yep.
Our lighting stick here has become slightly
it'll be okay.
problematic. Okay.
So again, same deal. We're going to light this, and I'm going to save our last candle. You're going to let it burn a little bit so the wick starts to go, and then do the same thing. Bring it right down into the top. Bring it right down in there.
Oh, yeah. Oh, okay. Now that was a cool one because we were able to see it before it went away.
That one was a little bit slower because in that isopropyl alcohol, there's a little bit of water.
Oh, okay.
And so I'm slowing down the combustion a little bit.
All right.
Now our last one here is methyl alcohol. Now methyl alcohol actually has an ability to be, it's very volatile.
Oh boy.
It turns into vapor really, really quickly.
Love that word early on a Saturday. Okay.
Should have warned you that ahead of time. So we got one candle here. We're going to do the same thing. This is methyl alcohol.
Okay.
We're going to light you up here, and we're going to do the same thing. Just bring the flame right into the neck of the bottle.
All right. You tell me when.
Just bring it right in.
Okay.
Put it in there.
Okay. Woo!
Yeah.
Oh, wow.
Okay.
Wow, and we heard a sound. Oh, no.
And it's melting a little bit because it is still on fire. So come this way.
Okay.
Check this out. What actually happened there was our bottle, here's a slow motion version of this. I filmed this the other day. When it first combusts, the vapors inside the jug ignite. That gas begins to expand. We shoot that jet of flame out the top of the bottle.
Which we saw really quickly.
Which happened really, really quickly. Okay. This is like 4,000 frames per second. But you can see as the flame begins to consume all the oxygen inside the jug, give it a second here, what's going to happen is it's going to use up all the oxygen.
Yes.
The flame went away. Now, watch. Air's coming in, flame's going out. Air's coming in. That was that whoosh, 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 whoosh.
That we heard.
As the gas expands, it then begins to cool down because it used up all the oxygen. Gas contracts, pulls in more oxygen, combustion happens again, gas shoots back out.
And that's why then we wind up,
that was that oscillation.
Run back over here. That's why we wind up with this, because we had flames inside of here, and this is plastic.
In fact, I think this guy we didn't drain it enough, and it had some liquid on the outside.
So what you were talking about in the beginning, though, if you have that extra liquid, and you mentioned the word volatile, I mean, this is still hot to the touch.
Yeah. Absolutely. But that was a great oscillation. That's why they call it the whoosh jug, because it goes whoosh, 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 whoosh.
Yeah, and we're both still alive.
Yes.
So I'll see you next Saturday, Carl. Well, a little bit of heart palpitations. Everybody's good here. A lot of fun. You can see stuff like this happening down at the Imagination Station. And guess what? It's Saturday. That means if you live in Lucas County with a paid adult, children 12 and under get in for free. Thanks so much, Carl. See you next week.